This is Sheldon. Sheldon's a regular guy. He likes playing cards, drinking beer, playing Xbox. He's an ordinary looking guy. Some might say very ordinary looking. But his coolness factor is off the Fonzie scale, ladies and gents, because Sheldon's a freaking helicopter pilot. Now, we all know instinctively and from an early age that helicopters are awesome. But what's even more awesome is when you work out how these things stay in the air and how you fly them. So let's have a quick look at the basic dynamics of helicopter flight. As we all know, there's one big rotor on the top to provide lift and a smaller rotor on the tail to stop the chopper from spinning off out of control. But let's take a closer look at how they work. Each rotor blade is shaped kind of like the wing of a plane, but with two key advantages. Firstly, since it's spinning at high speed, it can develop lift even when the aircraft is hovering still in the air. Secondly, the rotors can tilt to produce more or less lift using this nifty bit of engineering called the swash plate. So here's how the controls work. Down here, where you might find the handbrake on a car, you've got the collective control stick. It's got a twist grip throttle on the end, much like a motorcycle throttle, that controls the speed and power of the rotors. When you pull the collective upwards, it pushes the swash plate up, tilting the top rotor blades into the wind and generating enough lift to get the chopper off the ground and rising. At your feet, a pair of pedals manages a similar process at the tail rotor. Pushing the pedals alters the tilt of the tail rotor, which is spinning at a constant ratio to the speed of the top rotor. As you lift off, you need a touch of extra pedal on the right to balance out the torque effect of the main rotor. And after that, you can use the pedals as kind of a steering wheel to rotate the chopper 360 degrees in the air. But the really interesting control is the cyclic control stick, which effectively lets you control the tilt and acceleration of the helicopter in any direction. Here's how it works. Here's a top-down view of a helicopter in flight. In a stable hover, you can look at the main rotor as a fairly evenly balanced disc of lift. When you want to move off in a particular direction, you do it by creating extra lift at one particular point in this disc. And here's where we come back to that incredibly clever swash plate. When you move the cyclic control stick to the left, the swash plate tilts so that the left side is lower and the right side is higher. Now what that means is that as the rotor blades spin around, they flatten out and produce less lift as they approach the left side of the aircraft, and they tilt up and produce more lift as they spin around to the right-hand side. So the disc of lift becomes unbalanced, the whole helicopter tilts over in the desired direction, and you start moving at speed. Clever, huh?
Two great moments that stick out to me in my flying career so far would be landing a helicopter in the snow of the Southern Alps in New Zealand, as well as flying over the city of Melbourne eye to eye with the 9 to 5 workers in their skyscraping buildings. If you think flying one of these looks like fun, it really is. I recommend anyone do it, so best you come in and see somebody like us and get some flying lessons done, and maybe you can get a future career in flying a helicopter.
You know, basic helicopter lessons are not all that expensive. So if you like the idea of flying one of these beasties yourself, get in touch with a local flight training business and have a crack at it. This is Loz Blaine, over and out for Gizmag.